What if 42,000 years ago our planet's invisible shield nearly vanished and that single event helped shape human evolution? About 42,000 years ago, something extraordinary happened deep beneath our feet. Inside Earth's molten heart, where iron churns and spins like a vast liquid engine, the invisible shield that protects our planet began to falter. Scientists call this the Lachamp excursion, or the Adams event. For reasons still not fully understood, Earth's magnetic field collapsed to a fraction of its normal strength, perhaps only 6 to 10%, and for short moments, maybe close to zero. Imagine the geodynamo sputtering, the planet's magnetic breath growing weak. Without that invisible armor, the magnetosphere, the bubble that shields us from cosmic radiation, shrank dramatically. Auroras once confined to the poles flared across much of the world, painting the skies of Europe, Asia, and even the tropics in ghostly light. But what looked beautiful from the ground was a warning from the heavens. Cosmic rays and solar particles, normally deflected harmlessly into space, now rained through the atmosphere. Radiation levels spiked, climates wavered, and the delicate balance of life began to tremble. For centuries, Earth's pulse slowed and its protection thinned. In that fragile moment, the rules of survival quietly changed, and everything living on the planet had to face a world suddenly exposed to the fury of space. As Earth's magnetic field faltered, the planet's once mighty shield began to collapse inward. Normally, our magnetosphere stretches 10 Earth radii into space, a vast invisible cocoon deflecting the solar wind. But during the Lachamp event, that barrier may have shrunk to less than a quarter of its size, only about 2.4 Earth radii. The consequences were staggering. Charged particles from the Sun and distant supernovae, once kept safely at bay, now surged through the thinning defenses. The auroras, those ethereal curtains of light that usually dance near the poles, spread far south, streaking across mid-latitudes and even into the tropics. Imagine ancient humans in Africa or Europe, staring up at skies glowing green, red, and violet colors of both wonder and danger. But this beauty came with a cost. As high-energy particles collided with the upper atmosphere, they sparked chemical reactions that formed nitrogen oxides, invisible yet destructive agents. These compounds tore through the ozone layer, shredding the planet's natural UV shield. For the first time in human prehistory, sunlight itself became a threat. With each day's dawn, the Earth was bathed in harsher ultraviolet radiation, reaching ground levels never seen before. Our atmospheric umbrella had been pierced, and the full force of space was bleeding through. When the ozone thinned, the sun's rays grew sharper, more merciless. Invisible but deadly, ultraviolet radiation began to slice deeper into the atmosphere, touching places it had never reached before. The first to feel the sting were the plants. Across open savannas, along tundra edges, on wind-swept highlands, the world's green engines began to falter. UVB light, potent enough to scar DNA, tore at the delicate machinery of photosynthesis. UVC, normally stopped high above, now penetrated further, damaging cells that had no natural defense. Leaves blistered, pigments faded, and the rhythm of growth slowed. With less ozone and more cosmic radiation, the planet's ecosystems wobbled under invisible pressure. Grasslands thinned, shrubs withered. The productivity of tundra and steppe collapsed. When plants suffered, everything else followed. Herbivores found less to eat. Their migrations lengthened, their numbers dropped. Carnivores, too, felt the slow hunger ripple through the chain. Insects shifted range. Birds lost nesting grounds. This was not a sudden apocalypse, but a drawn-out unraveling. Climate, radiation, and ecology all moved out of sync, each amplifying the other. The planet wasn't dying, but it was changing fast, and every species, from the smallest moss to the tallest hunter, was forced to decide, adapt, move, or disappear. The timing is more than coincidence, it's a crossroads in our story. Around the same moment, Earth's magnetic field faltered. One human species vanished, while another began to bloom. Neanderthals, resilient, intelligent, perfectly tuned to the cold steppes of Ice Age Europe, started to fade from the fossil record. Their heavy bones, their tools, their fire-lit caves, all fell silent. And in their place, Homo sapiens, our ancestors, began to carve symbols, paint walls, and dream in color. Some scientists wonder if the weakened magnetic field changed the rules of evolution itself. With less protection, radiation at the surface surged. The pale-skinned Neanderthals, adapted to low UV northern skies, suddenly found themselves under ultraviolet levels. Their biology wasn't built to endure. DNA damage, reduced fertility, subtle health effects, tiny disadvantages that over generations became fate. Meanwhile, Homo sapiens, carrying darker pigmentation inherited from African ancestors, had a natural shield against radiation. Under the new, harsher sun, that genetic armor became an evolutionary edge. But radiation wasn't the only stress. Climate chaos fractured habitats, food sources shifted, and survival demanded adaptability, social, cultural, and cognitive. Those who could innovate, migrate, and cooperate thrived. In the crucible of the Lachamp event, evolution didn't pause, it accelerated. Under pressure from the sky itself, one branch of humanity disappeared, and another stepped forward to rewrite the story of the species. Under the strain of radiation, cold, and scarcity, Homo sapiens didn't simply endure, they adapted with imagination. Where nature withdrew its protection, culture stepped in to replace it. Around this turbulent window, the archaeological record bursts with new signs of creativity. Caves across Europe and Asia ignite with color ochre reds, charcoal blacks, and glowing yellows smeared by human hands tens of thousands of years ago. These weren't random marks. They were messages, prayers, warnings, memories preserved in stone. Ochre, an iron oxide pigment, may have been more than symbolic. When mixed with fat or resin, it forms a protective paste, a primitive sunscreen. In a world flooded with ultraviolet light, painting the body may have meant survival. The ritual became protection. The art, adaptation. Caves themselves became sanctuaries. Thick walls blocked radiation and the biting winds of a volatile climate. Inside, small bands of humans huddled together, sharing warmth, stories, and new ideas. It was here, in darkness lit by flickering firelight, that modern behavior took root. Symbolic art, social bonding, language, music, and myth. The environment had forced humanity to look inward, and what emerged was the first spark of culture as we know it. In turning fear into creativity, Homo sapiens discovered their greatest evolutionary weapon, imagination. The Lachamp event did not test humans alone. It reshaped the entire living world. Across the continents, the great beasts of the Pleistocene, mammoths, woolly rhinos, giant kangaroos, saber-toothed cats, began to vanish. These animals were built for stability. They bred slowly, required vast territories, and thrived in predictable climates. But when Earth's systems slipped into chaos, radiation surging, ozone thinning, temperatures swinging wildly, their strengths turned to weaknesses. The ultraviolet spike singed the base of the food web. Plants withered, grasses lost vitality, and tundra lichens failed to recover from each harsh season. As vegetation faltered, herbivores starved or wandered farther, their ancient roots disrupted by drought and cold. Predators, in turn, followed the collapse downward. From Australia's arid plains to the mammoth steppes of Eurasia, the same pattern unfolded, abundance giving way to silence. For these giants, adaptation came too slowly. The world was changing faster than their bodies could respond. But one species adjusted in real time. Homo sapiens shifted diets, built tools, sought shelter, and learned to control fire and pigment. Where the megafauna fell, humans adapted using intelligence instead of size, cooperation instead of muscle. The fall of the great animals mirrors the story of resilience itself. Nature's giants succumbed to the planet's turmoil, while its smallest, most curious descendants learned to bend with it, and in doing so, began to shape the future. The Lassamp event was not a one-time fluke, it was part of a deeper rhythm in Earth's restless heart. Our planet's magnetic field, born from molten iron currents swirling in the outer core, has reversed or collapsed many times throughout geologic history. Scientists call these moments geomagnetic excursions, short-lived failures of the geodynamo. During the Lassamp excursion, the field's main axis, the dipole that gives us north and south, nearly vanished. The magnetosphere didn't disappear completely, but it twisted into chaos, forming multiple poles and strange magnetic zones. Compasses, if they had existed, would have spun aimlessly. As the field lost its order, cosmic radiation flooded in, leaving clear fingerprints in ice cores and ancient sediments, spikes of beryllium-10 and carbon-14 that mark a planet exposed. These traces are time capsules, silent witnesses to a world that briefly lost its shield. From a geophysical standpoint, Lassamp reminds us that the magnetic field is alive, dynamic, pulsing, and imperfect. It drifts, wobbles, weakens, and occasionally flips entirely. Its instability has planetary consequences. When it falters, radiation seeps in, climates shift, life feels the pressure, and through it all, the molten engine at Earth's core continues its slow, unseen dance, the rhythm that protects, transforms, and occasionally tests every living thing above. The story of Lassamp is not ancient trivia. It's a reminder that even the planet's greatest defenses are built on motion, not permanence. It's easy to think of the Lassamp event as ancient history, a relic of prehistory with no bearing on the modern world. But our civilization now depends on the very thing that once failed, the stability of Earth's magnetic field. Today, we live inside a web of fragile technology. Satellites orbiting above us depend on magnetic orientation and radiation shielding. Airplanes navigate through polar routes where cosmic radiation already pushes the limits of safety. Global power grids hum in delicate balance, vulnerable to even small geomagnetic storms. If Earth's magnetic field were to weaken as dramatically as it did 42,000 years ago, the consequences would ripple through everything we take for granted. GPS systems could falter, communication satellites could fail, and radiation at flight altitude or aboard the International Space Station could spike dangerously. And signs of change are already here. The dipole moment, the strength of Earth's core-generated field, is steadily weakening. Over the South Atlantic, a vast dent known as the South Atlantic Anomaly exposes satellites to higher radiation, occasionally knocking them offline. We haven't seen a full magnetic excursion in nearly 780,000 years, but the pattern of drift and decay suggests the system is far from stable. The lesson from the past is not fear, it's awareness. The shield that protects our planet is alive and unpredictable. It has failed before. It will fluctuate again. And in a world bound by technology rather than instinct, our survival now depends not on adaptation of the body, but adaptation of the mind. What if the heartbeat of our planet, the molten iron churning thousands of miles below, suddenly faltered? What if the invisible shield that has guarded life for billions of years thinned, and the universe itself came rushing in? 42,000 years ago, it did. The Lassamp event reminds us that Earth's magnetic field is not merely a background feature of physics, it's a living force, woven into the story of evolution, extinction, and survival. When that shield weakened, life on Earth was tested. The skies shimmered with strange auroras, The air thinned of ozone, and radiation spilled across continents. In that crucible, some species vanished, others adapted. For Homo sapiens, it was a trial, but also an awakening. The pressures of radiation, climate, and scarcity forged creativity. We turned caves into sanctuaries, ochre into armor, and art into memory. What began as survival became culture. What began as fear became meaning. Our ancestors endured because they could transform adversity into innovation. Their resilience was not just biological, it was imaginative. The Neanderthals fell silent. The megafauna faded, but humanity learned to live with a changing planet. That legacy still runs in us. The instinct to adapt when the earth itself shifts beneath our feet. The Lasham pulse may have reshaped our destiny once, and it warns us still. The same molten engine that gives us protection can one day test us again. And perhaps, when it does, our greatest shield will not be magnetic, but human. If you're intrigued by the hidden forces that shaped our ancestors and the wild interplay between planet and people, subscribe to Prehistoric Shadows and join us as we explore our deep time journey through shadows and light.